I'll put them up on my YouTube channel, which remember is linked to the links page. Okay. So why don't we do this speed of Pac-Man one first, and then we'll do a graphical one. Okay? So in this one, they're asking us to calculate the speed of Pac-Man. I'm assuming everyone knows what Pac-Man is. Is that an okay assumption? Yes? Okay. And as he moves across the screen, and then they say we're going to play with different units, we'll probably just do it in our base units. All right? So we've got Pac-Man there moving across the screen, and we can do the timing. So in our Y for this, we would want to make sure we show that we understand the difference between speed and velocity, right? So speed is is the rate distance changes. And by rate, we're always, the rates in here will be like always per time, but you could have rates for other things, right? Like, if you're in calculus class, you would have, like maybe volume per height or something like that. Rate, how does the volume change compared to the height, change in height? So some people might add after this with time, or with respect to time. So that's the main concept, but now we need to add something that brings the Y to this exact problem, right? What could I talk about that would bring it to this exact problem?
It doesn't matter. Velocity.
Okay. One thing I think of is the faster he moves, the longer distance in the same time. I could also say, he'll cover the same distance in less time if he's moving faster or slower, but something just to bring it to the problem we're looking at. Yes? No, maybe?
So I guess it's short
they're the example problems that you have a copy of them in your drive from when we did them, probably 10 assignments ago. Or just look in your drive and search for example problems. It may be the only one in there. All right, so now we have to take some data here. We got to start the timing and then stop the timing. I know the timer is going to start at 0. Where should Pac-Man be when we start the timer? Come on, we're doing this together. You guys decide. At like 10? Okay. And then where will Pac-Man be when we stop it? 50?
Right here.
So go from 10 to 50. You guys tell me. 10 to 50. We're going 10 to 50. Okay. So I'm going to hit start when he gets to 10. And then when he gets to 50, we'll stop the timer. All right. So we know it took 5,680. What's that little M stand for? I couldn't hear you.
That one's on.
Milliseconds. The M stands for milli, and then S for second. So 5,860 milliseconds to go from 10 to 50. So what's the distance from 10 to 50? 40. 40 centimeters, right? All right, so I'm going to 5,680 milliseconds. My equation, from my equation sheet, is really for velocity, right? Velocity is the displacement per time. But I know for speed, it's just distance per time. Right?
I guess
I don't know.
Get close.
4, 5 maybe?
14%.
Look for something with a link that has the word Pac-Man in the link. So, the distance we said was 40 centimeters, right? And the time was 5,680 milliseconds. I don't like working in centimeters and milliseconds. So I think I'll plug them in meters and seconds. So speed, my distance, I'm not going to put in 40 centimeters. I'm going to put in 0.4 meters.
It can be boring to watch, but I like watching.
Remember, if you don't know like centi and millions, that's on the back of your equation sheet. And then the time I'm going to put in as 5.68 seconds. And I can't do that in my head. So 0.4 divided by 5.68. 0.070 meters per second. My guess is they're going to want it in centimeters per second too. So that would be 7.04 centimeters per second. So my Y for this should show that I understand.
That's a stretch.
All right, so my Y should focus that I understand how, from a position time graph, do I know how can I have a clue about the velocity? Well, I should show I understand what velocity is. So something like velocity is the rate, the displacement changes. And then slope is the rate a graph changes so the slope of a displacement, which is also position graph, is the velocity. So I've shown I understand the concept and tied it to this problem because I have a position time graph for this problem. Yep. You knew that, so I'm sure you knew that. Pretty sure. Pretty sure. Yeah, Adam definitely knows. Yep, yep. Okay. Well, distance is how far you've traveled. Displacement is how far you are from where you started. So, from a position time graph, you can actually get both, right? Because, like, from this graph, the displacement is going to be the change in position. So, like, on the red line, distance and displacement are going to have the same values, right? Except distance would be negative because it has that direction. On the green line, distance and displacement are the same value. But if I went from, like, okay, where I was at 10 seconds to where I was at 40 seconds, the displacement would just be the change in position less than 50. But the distance would be however I traveled. You know, I went from 210 all the way down to 40, which means I traveled like 170, and then I went back up to 240, so that's another 200, so that's 370. So with distance, I have to add up that whole path length. Displacement, I don't care about the path at all, just the starting and ending points. That help. So the graph wouldn't be different. The graph is showing you where you were at each time, but how you pull the information from that graph depends upon the definition of what you're looking for. Okay. Great question, by the way. That was really a good question. All right, so we're looking at the velocity for the red section, the green section, and the blue section. Oh, the blue section is pretty easy. What's the velocity for the blue section? 0, because what's the slope of the blue section? 0. No, I don't even need to show work, right? I just got it. Easy. So, let's do the red one. Because red one uses a little more. What time are we done, by the way? It's on the sheet. The agenda's in front of you. $9:39. So, like right now. But basically, I would take the slope of the red section. You know, I do rise over run. Am I going to get a positive or a negative value for the red? Negative. So I'm going to pick like a point here, right? Like right here. And know that has, let's see, that has coordinates like 5 seconds and 235 meters. And then I'm going to pick another one down here, like right there, and I know that has a time of 20 seconds and let's see, that'd be 50, 60, 70, 75 meters. And then I'm going to do rise over run because that fits with my velocity equation also. One thing you'll never have is never have negative time. So remember that it's always final minus initial, right? When you're doing the slope. Yes? Yeah, because it's a negative slope. And then, right. All right. I think